So let me explain next topic. All of you please write down. Next topic is circular motion. All of you please write down circular motion. The chapter name is motion in a plane. Now motion in a straight line was the second chapter. In motion in a straight line, we are dealing with the motion along a line. Motion along a line means either body may be going towards right or the body may be going towards left side, like that. Only that kind of motion is motion along a straight line. We studied in the second chapter. But here in the third chapter we are learning the motion in a plane, not in a line. So circular motion is an example for this motion along a plane. Circular motion, for example, motion of the planet. In the previous class I have given you the introduction. The motion of the planet, for example, motion of the earth. Motion of the earth around the sun. It's an almost circle. It is an example for circular motion. Understood? So another example, yes, for example, suppose you have a rope or string. Okay, rope or string. Let me record the class. Suppose I have a rope or string, a ball, a stone is fixed on one end and I am holding the other end. I can rotate it. If I rotate it, the stone will be moving along a circle like this. Understood? Is it a motion along a line? No, it is not motion along a line. This is said to be circular motion. It is an example for motion in a plane. Plane means this shaded one is a surface, right? Plane surface. The stone is moving along this plane surface. Okay, anyway, the motion, circular motion we are going to learn. Okay, circular motion. There are certain important terms associated with the circular motion and there are two important derivations. Initially we will not learn the derivation, but derivation is definitely there in the syllabus. After doing certain problems I will discuss the derivation. That is the right way. If I discuss the derivation in the beginning, it is very difficult to understand. Once we have done a few 2 or 3 problems, you will be familiar with each terms. If you are familiar with each terms, then the derivation is much easier to understand. So definitely I will discuss the derivation, but initially we just memorize the formula. So let me start then. Circular motion. All of you please listen. In our syllabus, in circular motion, it is divided into 2 types. I will tell you. In circular motion, in our syllabus, we have to learn uniform circular motion. Uniform circular motion. The non-uniform circular motion is there, but it is there in the another chapter, system of particle and rotational motion. In that chapter, we will learn more about non-uniform circular motion. What do you mean by uniform circular motion? What do you mean by uniform motion? Anybody? Can you tell me what do you mean by uniform motion? Have you heard about that term anywhere?
Sir, going in the same path continuously.
No, not that like that. Let me define uniform circular motion. All of you please listen. Suraj, let me call Suraj because in the next class you have to rename it. Suraj, if you don't understand anything, you can ask me doubt. Don't worry. Initially you will face a little difficulties, but later it will be all right. Okay? Understood. So listen, I am going to discuss about the uniform circular motion. Consider this is the circular track. Understood? This is the circular track on the ground. Suppose I am driving my bike. Okay, I am going through the circular track. I mean through my bike. Okay, think like that. I am riding my bike. If I ride my bike with the same speed, I'm not talking about velocity. If I ride my bike, the speedometer will be there, right? in the bike there is a speedometer like 0, 1, 10, 20 like that. If I maintain the fixed speed, I am traveling in a bike along the circular track. I can maintain a fixed speed while I am traveling. If I am traveling with the same speed along the circular track, it is said to be uniform circular motion. I am not increasing my speed. For example, I am moving with a fixed speed, say 30 km per hour. If I am moving with a fixed speed along the circular track, then such circular motion is said to be uniform circular motion. So my speed, the speed, it is denoted by v. If I consider the direction, we can call it as velocity. For the time being, I am not talking about direction. Speed, let us call it as v. So let that speed is nothing but the speed is the distance covered. Speed is the distance covered in unit time, understood? In 1 second time. In 1 second time, how much distance the bike covered, bike traveled. In 1 second time, how much distance the bike traveled. That is said to be speed. So, if the speed is fixed at every point, we call it as uniform circular motion. So, uniform circular motion is the motion, the motion along a circle with a fixed speed. That's all. Let me write in within bracket with the motion with a fixed speed. Speed, you know that in 1 second how much distance I traveled. That is speed. So uniform circular motion, have you understood? Motion with a fixed speed. Is that okay? Clear? Rakshana, Shivani, Deva, Aryan, everyone is clear?
Sir,
Okay.
Yes, sir.
Let me explain this kind of traveling. I am traveling in a scooter or bike, maintain a fixed speed. Then it is said to be uniform motion. Now listen, there are certain terms associated with the circular motion. I am going to explain every terms. And we will I will explain the formula. We will do the problems. In that case, we will be familiar with each terms. So let this be the center. Okay, let this be the center. Initially I was at A. Okay, initially I am standing at A. I travel through along a circular path, and I reach a point B. Initially I was at A, and I am traveling with a fixed speed, and I finally reached B. Let me join from center. Okay. The center has a role actually. Okay. So in A was the initial position. Let me write here. Otherwise you will forget it. Initial position. And B is the final position. I am moving with a fixed speed. And if I travel from A to B, I can say that I covered some angle. Suppose this radius is r. Okay, the circle will have a radius, right? Let it be r. Okay, so 1 minute. Yes, r is there, and okay. Yes, there is a small angle here. That small angle let us denote by delta theta. Delta stands for small value, understood? Or d theta. In some books it is written as d theta. D theta means a small value of theta. That's the meaning. Does not mean d into theta. D theta does not mean d into theta. D theta stands for a small angle I rotated. I am traveling from A, and I traveled a small distance and finally reached B. In that case, I can say that I covered a small angle at the center. Let it be d theta. Okay. So d theta has a name. Let me write important terms here. R is the radius of the circle. I will definitely interact with you, but let me explain some 3 or 4 points. After that, you can ask me doubts. R is the radius. D theta, there are so many terms associated with the circular motion. d theta is the angular displacement. D theta has a name. What is the name of that? Angular displacement. All of you are familiar with the trigonometry? Let me ask you. All of you are familiar with the trigonometry? In trigonometry, there is a topic angle. Have you studied, Suraj? Have you studied trigonometry? There is a topic angle. Okay. The angular displacement. We are not using the unit as degree. Please mute your audio. For angle, here in circular motion there is a standard unit. We don't use degree measurement. We use radian measurement. The unit must be radian. It is important. The angle has actually two units. One is degree, other one is radian. You might have studied about radian measurement in the chapter trigonometry. There is a chapter trigonometry in maths. If you don't understand, you can ask me. So d theta is the angular displacement. Okay. So if I travel from A to B, I travel some distance. Okay. I travel some distance. Okay. That part is clear. Okay. Then next is, let me explain each and important terms. V is the linear speed. V is the linear speed. It must be fixed. Why it is fixed? Because I am talking about uniform circular motion. I am moving with a fixed speed. I told you initially, fixed speed. Let me explain every terms, and after that I will explain the formula. V is the linear speed. Okay. And there is another term. V is given by. What is V? How will you find out V? Anybody? Tell me. How will you find the speed? Please tell me. Aryan, എങ്ങനെയാണ് V കാണുന്നത്?
That is speed is equal to distance by time.
Yes, very good. To find out the velocity, let me call it as speed. The speed is given by the distance covered divided by time. Suppose it took dt time from traveling from A to B. Suppose I took time, a small time dt is required for traveling from A to B. For traveling from A to B, it took time dt. So in dt time, I travel from A to B. So I got an angular displacement d theta. Understood? So V, how will you find out V? In order to find out V, suppose the distance between A and B. The distance, let me denote it by some letter. You can tell me some letter. Let it be ds. ds is the small distance I covered. Normally S is denoted by as the displacement, right? So from A to B, I covered a small distance, say ds, in a time interval dt. In a time interval dt, I travel a small distance ds. So the velocity is given by the distance divided by time, or ds by dt. Whatever formula I put it in a box, you have to memorize it. The velocity is equal to ds by dt. ds stands for a small displacement. dt is the time required, time taken for traveling that distance. So distance by time is the speed, right? Sometimes we call it as velocity. Okay, anyway, linear speed is equal to ds by dt. The linear speed stands for the speed along the track. If I don't say like that, you will be confused next time. The linear speed means speed along the circular track. Let me write like this. If you memorize like this, you will never forget it. Speed of the body along the circular track. Along the circular track means I told you I am traveling using my bike along the circular track. I maintain a fixed speed. Okay, so the speed of my bike along the track is said to be linear speed. Okay, what will be the unit? Tell me, what is the unit of linear speed? Anybody? Please tell me, Suresh, you please tell me what is the unit of speed? Suresh? Speed unit? You don't know. Unit of speed is what?
Sir, meter per second.
Ah, yes, meter per second. Meter per second. Rakshana understood? Clear? Rakshana? Unit of speed is meter per second. So far what we have studied, r is radius, d theta is the angular displacement. If I travel, definitely I cover certain angle at the center. V is the linear speed. What do you mean by linear speed? Linear speed means speed of my bike. Let me say like that for the time being. Speed of my bike along the circular track. It is meter per second. Okay. Because there is another type of speed. Okay. That is why I am stressing this point. So there is another point. Let me give a heading, or let me write a symbol for that. Omega. There is another Greek letter is there. It is written like omega W, but it is not exact. It is not W, not read as W. It is omega. It is a Greek letter. Omega is the angular speed. There are two types of speed we can define. One is linear speed. It is the speed of the bike along the track, meter per second. There is another speed which is angular speed. As the name suggests, what will be the definition? Angular speed means in 1 second how much angle I cover. Angular speed means, let me write as a simple definition. Angular speed means speed at which, or let me write in sentence like this. Angle covered in 1 second time. In 1 second time, how much angle I cover at the center. That is said to be angular speed. Speed of the angle, understood. Speed of the angle is angular speed. So in 1 second time, I am traveling using my bike like this. In 1 second time, how much angle I will cover at the center. As I am riding my bike, definitely I am covering angles continuously. So as I am traveling along a circular track, in 1 second time, how much angle I will cover at the center. Understood? That is angular speed, angle covered in 1 second. So omega is given by, suppose for example in dt time, definitely I will interact with you after writing this formula. Okay, suppose in dt time interval, in a small time interval dt, I covered an angle d theta at the center as per this diagram. In dt time interval, I covered an angle d theta at the center. Then in 1 second, how much angle I will cover? The angle will be, in 1 second I will cover this much angle, d theta by dt. I will repeat, don't worry. In dt time, I cover d theta angle. Understood? In dt seconds, I cover d theta angle at the center. So in 1 second time, how much angle I can cover? In dt second, d theta angle I can cover. Then in 1 second time, how much angle I can cover? D theta by dt. So d theta by dt is the angular speed. Angular speed is the angle covered at the center in 1 second time. Let me write the unit. After that, you can ask me doubt. Let me write the unit. The unit is, you know that d theta is the angular measurement, right? D theta is the angular measurement. I told you its unit is radian. Angle has two units. One is degree, other one is radian. we don't use degree measurement, we use only radian. Normally in physics, or in any engineering field, we prefer degree, not we prefer radian measurement, not degree. So d theta numerator has the unit radian. dt denominator is dt, which is having the unit second. The unit is important. So omega is having unit radian per second. Linear speed and omega, most of the students confuse between v and omega. When anybody talk about v, you think like this: it is the speed of my bike. Okay, it is simply the speed of my bike, nothing mentioned about angle. That is linear speed, speed of my bike. My bike will have a speed, right? That is linear speed. But omega is about angle. In 1 second time, how much angle is covered in at the center? That is omega. Unit is radian per second. This omega will be fixed. For a uniform circular motion, this omega and v both will be fixed. Omega does not vary. So all of you please write down all these important terms, and if you are 100% clear till this step and written everything, raise your hand. Suraj, there is a button in Google Meet, raise hand button. You might have seen that. You just click if you are 100% clear and written everything.
Yes, sir.
Fadil understood. Rakshana, Aryan, Aaron, Suraj. Next time you can rename it, okay? Or you can send me a WhatsApp message. I will save your name. Okay. So all of you please write down. If you have written 100% clear, then only raise your hand. If you don't understand any point, you please ask me. Okay, I will clarify. Devasri Shivani, you are writing, right?
Yes, sir.
Okay, okay. Please write. Write it fast, Shivani. And ask me doubt if you don't understand any point. Not completed. Devasri Shivani, not completed. Hello. Completed. Okay, okay. Shivani, do you have any doubt, Shivani?
No, sir.
You are still writing. Write it fast, taking too much time. Or else you take screenshot. Okay, you are taking too much time, Shivani. I will send the PDF class note. I will send it. Okay, Shivani. Is that okay?
Yes, sir.
Okay, I will send everyone, for everyone I will send the class note today onwards. Okay. So all of you please listen. So V omega, everything is clear. Okay. So one formula, there are two derivations. One derivation I will discuss right now. The second derivation, another one regarding acceleration, I will discuss. I will discuss it later. Okay. So V and omega, let me give a heading. One derivation I will discuss right now. The derivation is not difficult, that's why. Relation between linear speed and angular speed. You please write it as a heading, angular speed. Linear speed means V. I have discussed many times. Linear speed means speed of my bike. Angular speed, speed of the angle. Okay. So V and omega, is there any relationship? Yes, definitely there is a relationship, but you must know the trigonometry. In the beginning of the trigonometry, there is a topic, radian measurement. You must know that topic. But the derivation will not take too much time, hence let me discuss the derivation. So look at this diagram. In trigonometry, you studied that the center angle which is in radian measurement, right? The center angle which is measured as the radian. As per the definition of radian, this d theta is arc length by radius. If you don't know, just memorize it. You will definitely learn in trigonometry. The center angle is in radian measure. In that case, the center angle is equal to arc length. Can you see a small arc here? Arc length by radius. I will write it in sentence so that you will never forget it. Center angle. I don't want to draw the diagram again. Center angle equal to, but the center angle should be in radian measure. Otherwise, this formula is not valid. The center angle should be in radian measure. Center angle is equal to arc length divided by radius. It is there in it is there in trigonometry. If you don't know, you please memorize it. Center angle in radian measurement equal to arc length by radius. Radius. So center angle, as per this diagram, the center angle is d theta, right? Arc length is it is marked as ds, right? ds. ds by arc length by radius. Radius is r. So if the center angle is measured as the radian measurement, we have a formula like this. The center angle equal to arc length by radius. There is a formula in maths. Arc length by radius. Just let me do the cross multiplication. The arc length is ds. R into d theta. If you don't understand, you can ask me. But let me complete it first. If I do the cross multiplication, ds equal to r d theta. ds is the arc length or the distance I travelled in a small time interval dt. So now I am going to write the formula of linear speed. Linear speed I have already discussed, ds by dt. In 1 second time, how much distance I travelled. ds by dt is v, I have already discussed. v equal to ds by dt. What is this ds? ds is nothing but it is the arc length. ds is the arc length. So ds is r d theta. ds is what? R d theta. R into d theta by dt. dt. Okay. Understood. ds is r d theta. Let us give a small bracket here. Understood. Let me give a small bracket. So v equal to linear speed equal to r into. What is this d theta by dt? d theta by dt means the angle covered in 1 second time. I have already written. Yes, very good. d theta by dt omega, I have already discussed that. This formula is very, very important. Not only important in this formula, I mean in this chapter, there is another chapter, system of particle and rotational motion. In that chapter we will learn more about rotation. We will learn more about rotation. In that chapter we frequently use this formula, V equal to R omega, extremely important. Please understand the derivation. It's a very simple derivation, so don't forget it. V equal to R omega. All of you please write down. If you have written and 100% clear, raise your hand.
Sir,
Tell me.
can you explain once again, sir?
I will explain. I will explain. Others, please write it so fast. Deva, you may take screenshot. Okay.
I took, sir.
It's very simple, Devasri. See, I don't know whether you. Please mute your audio. Please mute your audio. In trigonometry, you have already attended the chapter trigonometry. In trigonometry, you studied that the center angle, I mean the rotation is there. The center angle equal to arc length by radius. We have already studied in the chapter trigonometry. D
Yes,
theta is in radian measure. D theta equal to ds by r. It is in mathematics. D theta equal to ds by r. That is written here. Angle, center angle equal to arc length by radius. We have obtained this formula from mathematics trigonometry. Okay. I just did the cross multiplication. I get ds is equal to r into d theta. Just did the cross multiplication. ds is the arc length. Look at that diagram. Again and again I am telling you, ds is the arc length or distance I travelled. ds is the arc length or distance I travelled. So the arc length is equal to r into d theta. This formula I have already discussed. V equal to ds by dt I have already discussed. If you still have a doubt, you can watch the recorded class. This one I have already discussed. The linear speed equal to ds by dt. Distance by time is the speed, you know. So v equal to ds by dt I have already discussed. So we have a formula v equal to ds by dt. In this formula ds, right now I got ds equal to r d theta. Right now I got ds equal to r d theta. So this ds is replaced by r d theta here. Understood? This ds is simply replaced by r d theta. So r into d theta by dt. So you can watch the recorded classes also, no problem. I am recording this video. So ds is r into d theta, just replaced, and d theta by dt we have already studied. D theta by dt we have already studied omega, angular speed. So d theta by dt written as omega. So v equal to r omega. So please write down. Okay. So all of you please write down. If you are 100% clear and written the derivation, raise your hand. Suraj, do you have any doubt?
No, sir, but I have little bit in the V is equal to ds by dt. For that, how like dt came like in that formula?
D theta came. That is it your doubt?
Yes, sir.
Look here. It's very simple. Look here. You know that ds is r d theta, right? Understood? So instead of ds, can I write r d theta? Instead of ds, can I write r d theta?
Yes, sir.
And dt in the denominator side.
Oh, okay.
If I put a bracket here, is there any issue? If I put a bracket, there is no issue. Now you may read it as r into d theta by dt. Understood?
Yes, sir.
Hence r into omega. Okay, clear. So all of you please write down. Please write down. Everyone okay? Shivani, do you have any doubt? Shivani, you have not raised hand.
No, sir.
You understood. Acceleration. After the class, you have to read this note again. Acceleration. There are two types of acceleration. Acceleration, two types. One is linear acceleration or tangential acceleration. Don't worry about that. It's very simple. Don't worry. Tangential acceleration. Linear acceleration means the acceleration of my bike. Very simple. Okay. If the term starting with linear, you think about my bike. Okay. If there is linear, think about bike. I am traveling using my bike along the track. I told you that I maintain a fixed speed. I am not changing my increasing my speed. I am moving with a fixed speed. Then is there any acceleration then? If I am moving with a fixed speed, will there be any acceleration? Anybody? No acceleration, right? Shall I give any acceleration? No. If I am moving with a fixed speed, I am not increasing my speed along the track. While I am traveling along the track, I am not increasing my speed. If I am not increasing my speed, I can say that my acceleration is 0. This is 0 only for uniform motion. Only for uniform motion. So in this particular context, my bike's acceleration, linear acceleration will be 0. Linear acceleration means the acceleration of my bike. I am not increasing my speed, hence the acceleration along the track will be 0. Is that okay? Clear? Understood? Please respond. Please respond.
Yes, sir.
Okay. Linear acceleration 0. I am not giving any acceleration. Okay. I want to move with a fixed speed. That's why. So, but the next one is very, very important. There is another kind of acceleration. I will tell you. All of you please listen. Acceleration. In 9th standard you studied a formula. Please listen. Please mute your audio. In 9th standard and also in 11th standard, but in chapter laws of motion, do you remember this formula F equal to ma? Have you studied a formula F equal to ma?
Yes, sir.
Yes, sir.
Everyone studied.
Yes.
Can I define acceleration in this way? Is that okay? F equal to ma or a equal to f by m. We can define acceleration in this way also. Acceleration equal to force by mass. Force by mass means suppose a body experience a force. It is not necessary that the body is moving. It is not necessary that there is any visible movement. Not necessary. For example, if you apply some force, it is not necessary that the body is moving. Okay. I mean, if there is some sufficient friction. So, if I am applying any force on the body, then it will create an acceleration. Because F equal to ma or accelerate, F equal to ma, meaning that if F is present, acceleration is present. It is not necessary that there is any visible movement of the body. It is not necessary that any visible movement of the body. If F is there, definitely acceleration is there. Because of the formula F equal to ma. If F is present, yes, A is present. Okay, so let me take a simple example, not bike. I can give you another example, then only you can understand. This is the last one. Okay, suppose I have a rope. I have a rope. This is the rope I am holding. This point at the center I am holding, and at the end of the rope a body is connected having certain mass. I am rotating it. Do I apply any force on the body? Do I apply any force on the body while I am rotating it? Can you suggest? Please respond. Definitely, while the body is rotating, every time I am applying a force towards the center. Every time I must apply a force towards the center. So some force is necessary towards the center. If I do not apply the force towards the center, what happens? The body will escape from the circular track. So in order to maintain the body moving along the same circular track, every time I have to apply a force towards center. Every time. If I lose it, if I release it means I am not applying the force. If I release it, immediately it will escape from the circular track. So what I am saying is, to keep the body always in the circular track, every time I have to apply a force towards the center. You agree with me? You agree with me? Please respond.
Yes, sir.
Yes. Every time I have to apply a force towards the center. If I release it, no force is applying, it will escape. So the force towards the center is required. So since the force is there in the towards the center, definitely there is an acceleration towards the center. But there is no any visible movement towards the center. The body is not moving towards the center, but we are applying certain force towards the center. Hence, there is an acceleration towards the center. For acceleration, it is not necessary that there is any visible movement towards the center. Understood? Force is there, hence acceleration is there. So that kind of acceleration I am talking about. Okay? So, acceleration towards the center. Let me write the name of it. I will definitely repeat, don't worry. I will definitely repeat. The another type of acceleration is centripetal acceleration. Centripetal acceleration. This is the most important thing, AC. AC, it is defined as the acceleration towards the center. For a rotation possible, so the continuous rotation possible, every time I have to apply a force towards the center. Whenever the force is there, definitely there is acceleration. So the acceleration towards the center. Towards the center. If such acceleration is lost, the body will escape from the circular track. So this is centripetal acceleration. So that part is clear. The first part is not required. You need not worry about this thing. This thing actually there in the another chapter, system of particle and rotation motion. For your understanding, I just written that linear acceleration. Here that is not any significance here. For the uniform circular motion, the linear acceleration is not there. But centripetal acceleration is necessary. Otherwise, it will escape from the circular track. So centripetal acceleration is very, very important. Unit is meter per second square. Acceleration has the unit meter per second square, right? So this derivation is extremely difficult. I mean, difficult to understand. Difficult to understand. I will teach you the derivation once I discuss the problems. Once I discuss the problem, definitely I will derive this formula. So the centripetal acceleration is the linear speed we have already studied. The speed along the track. Centripetal acceleration is given by the formula v square by r. This derivation is very, very important. but I will discuss after doing certain numerical problems. So all of you please write down till this step, and if you don't understand any point, please ask me.
No, sir, can you explain this the again?
Which part centripetal acceleration? Still you have a doubt?
The rope one, sir. I didn't understand. Can you explain?
See, actually I am explaining the same thing what I discussed. See, I have a rope, a body is connected at one end, at the other end I am holding with my hand. I am rotating this body continuously. Rotating this body continuously. So, the rotation, the possibility of the rotation, I mean, to maintain the body in the circular track, to keep the body in the circular track, every time a certain force is necessary towards the center. Understood, Devasri? Certain amount of force towards the center is necessary. Otherwise, it will escape. It will escape. So there is a force towards the center. It is necessary. Whenever a force is there, there will be acceleration. Because F equal to ma. Understood? F equal to ma. If F is there, A will be there. Actually, the body is not moving towards the center. Actually, body is not moving towards the center, but a force is every time we are applying. A force is there, hence acceleration is there. Because of the formula F equal to ma. So, that acceleration is said to be centripetal acceleration. Centripetal acceleration is not there. If the centripetal acceleration is not there, the body will escape from the circular track. Okay. The formula derivation I will teach you later. Okay. All of you please write down. If you are 100% clear, then only raise your hand. 100% clear. Please write down, and if you are okay, raise your hand. Everyone is clear? Shivani, you are not responding, not raise your hand. Do you have any doubt? Shall I repeat anything, Shivani?
No, sir, no doubt.
No doubt. Let me discuss some one or two questions. Question is not difficult. The only thing is you have to memorize the formula. Only two formulas are there. Uniform circular motion. 1 minute, let me go to the exercise. Just wait. This one. All of you please listen. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed 900 km per hour. Compare its centripetal acceleration with the acceleration due to gravity. Not difficult question. All of you listen, all of you please listen. An aircraft, I don't want to draw the diagram of aircraft, it is very difficult for me. An aircraft moving along a circle, understood? The radius is 1 kilometer, it's not a small circle, understood? I am talking about the motion of the aircraft, plane. The aircraft is moving along a circle like this, looping, taking a loop. Aircraft is taking a loop moving like this with a fixed speed, right? The speed which is linear speed, the speed on the track, 900 kilometer per hour. Let us convert kilometer per hour to meter per second, because our unit is meter per second. That is why I have already discussed in the previous classes. Don't leave the class, please listen. How will you convert kilometer per hour to meter per second? Anybody? How will you convert kilometer per hour to meter per second?
Into 5 by 18.
Into 5 by 18. Rakshana, everyone, do you remember? Aryan, Fadil, sorry. Fadil, are you okay? Clear? Are you there in the class? Fadil?
Yes, sir.
Okay. Kilometer per hour can be converted to meter per second by multiplication with the 5 by 18. I have already discussed, never forget it. Multiply with the 5 by 18. So 1 minute, let me do the multiplication. 900 into 5 by 18. I don't want to discuss the multiplication part, that you can try. You will get 250 meter per second. The speed, what is that? What kind of speed is this? Linear speed. The speed of along the track. The aircraft is moving with a fixed speed. It is a uniform circular motion, right? That speed does not vary. But some kind of force is necessary. The engine has to do some kind of force to maintain the circular track. Some force is necessary towards the center every time. Every time the direction changes, every time with the help of engine or some other mechanism. By some other mechanism, some kind of force towards the center is necessary. If such force is lost, once such force is lost, that they cannot maintain in the circular track, keep in the circular track, it will escape gradually. So some kind of force towards the center is necessary. If force is there, definitely acceleration is there. Acceleration may be defined as the force per mass. Force per mass. One unit mass experience how much force? We may define like that. Okay. A equal to F by M. 1 kilogram mass experience how much force? Like that. So that AC I want to find out. AC is necessary to keep the circular track. So AC is necessary. I want to find out AC. The question is about find the centripetal acceleration. So I want AC. You know that the derivation I will teach you later in the next class. We studied this formula V square by R. V square by R. I explained that formula V square by R. V equal to 250 square. V square will be 250 square by radius. Radius is 1 kilometer. Should be in meter. You know that 1 kilometer is 1000 meter. You know that, right? Radius is 1000 meter. All of you clear till this step? Please respond. If you are 100% clear till this step, please raise your hand. If you are 100% clear, raise your hand. Devasri, you understood? Till this step you are okay?
Yes, sir.
So, the calculation I don't want to discuss. 625 by 10. You will get 62.5 meter per second square. With the help of some mechanism, some kind of centripetal acceleration is necessary, okay, to keep the circular track. Okay, so 62.5 is the centripetal acceleration. It is a direct question. We have to compare it with the acceleration due to gravity. Acceleration due to gravity denoted by g, right? It is approximately taken as 10. We need approximate value. G has the value 9.8. I have already discussed that. Approximately it is 10 meter per second square. Is that okay? Do you know the G, the value of G is okay? Is that clear? Understood? So our question, why I am taking G? Read the question. Compare it with the centripetal acceleration. So compare the centripetal acceleration with acceleration due to gravity, meaning that AC centripetal acceleration is how much times greater than acceleration due to gravity. That is the meaning. We just find the ratio. You will just find the ratio. In that way we will compare. In that way we will compare. Acceleration due to gravity is how much times greater than g. That is our question. You just take the ratio. AC is 62.5, g is 10, so 6.25. This indicate that centripetal acceleration is approximately 6.25 times that of acceleration due to gravity. Only the ratio is required. So all of you please write down, and if you have written and 100% clear, then only raise your hand. Okay. If you don't understand, please ask me. I am ready to repeat it. Okay. Aaron, Devasri, Suraj, Rakshana, Fadil, Aryan, clear.
Not write the unit, sir. That is the meter per second square.
Regarding you, which unit of which one you have a doubt?
After comparing the acceleration.
The ratio will not have any unit, because the numerator has meter per second square, denominator also has meter per second square. If I take the ratio, their unit will be cancelled. Meter per second square by meter per second square cancels, right? So the ratio will not have any unit. Ratio will not have any unit.
Okay.
So all of you please write down. And that's all for today's class. Next class I will discuss derivation, and one more problem I will discuss. In 2 class I think this chapter will be over. Okay. Suraj, I will arrange separate session for the other chapter. Okay. So if you have written and 100% clear, then leave the class. If you still have any doubt, you please ask me right now. Okay.
Okay.